So here we see 4 plots. Each of them shows 3 solutions of a second-order linear homogeneous differential equation with constant coefficients. And from the behavior of solutions, we've got to figure out the signs of the coefficients, so whether A and B are positive or negative. Now, I have there is going to be an extra lecture with kind of more details about this, but maybe now I'll just briefly explain what's going on here. So I hope it's going to be understood. If not, then you've got to watch the more detailed lecture. Now, what we see here is, so recall that the general solution of this differential equation is some constant times e to the power r1t plus some other constant e to the power r2t, where r1 and r2 are roots of the characteristic equation. Now, in plot A, we see that all solutions become unbounded when t goes to positive infinity, right? And all solutions tend to 0 when t goes to negative infinity, right? So this means that both r1 and r2 are positive. So r1 and r2 are positive. In plot B, we see the opposite picture, right? So all solutions tend to 0 when t goes to positive infinity, which means that r1 is negative and r2 is negative. Well, but then at the same time, recall from Viet's formula that r1 times r2 is b, and r1 plus r2 is negative a. And so now if r1 and r2 are both positive, it means that the product of r1 and r2, which is b, is positive, and the sum of r1 and r2, which is negative a, is also positive. So negative a is positive, so which means that a itself is negative. So a is negative. Now, in plot B, r1 and r2 are both negative, so the product of r1 and r2, which is b, is positive, right? And then the sum of r1 and r2 is negative a, and it is negative. So negative a is negative, so a is positive. Okay, so now we have identified, so we have figured out what happens in plots A and B. So in plots C and D is a bit trickier. So in plots C and D, R1 and R2 are of opposite signs. So one of them is positive, another one is negative. So in both A and B, say R1 is going to be negative and R2 is going to be positive. Right? So which means that in both cases, the product of the roots of the characteristic equation is negative. Well, but how can we figure out the sign of A? Now, so notice that what we see in C is that solutions, when t goes to infinity or to negative infinity, in both cases, solutions tend to be unbounded. So they approach plus minus infinity. Only in C, they approach negative infinity faster than they approach positive infinity. And if they approach negative infinity faster, it means that the negative root is kind of bigger in magnitude than the positive root. And if the negative root is bigger in magnitude than the positive root, then the sum of the two roots, r1 plus r2, is negative. While in D, solutions approach positive infinity kind of faster than they approach negative infinity. So you see it from the plot, right? So the pace when solutions kind of go to positive infinity is very, very fast. Right? So which means that the positive R2 in magnitude is bigger than R1. So the sum of R1 plus R2 is positive. Well, but then the sum of R1 and R2 is negative A. So if R1 plus R2 is negative, it means that A is positive. And if R1 plus R2 is positive, it means that A is negative.